Hi there, hello. Today we are going to be talking about absolute value equations. Before we get going on this, it helps to kind of understand what absolute value is. Absolute value is a distance from zero on a number line. So if you're looking at this is really asking you, hey, how far away is 3 from 0 on a number line? And a distance, my friends, is always positive. So your distances are always positive. So when you're thinking about absolute value, what's going to be coming out of absolute value will always be a positive number. So if I were to have a number line right here and I had 0, I could first start with a value of 3. Well, how far is 3 away from 0 on this number line here? Well, 3 would be 3 spaces away from 0. The absolute value of 3 is 3. Now we can talk about the absolute value of negative 3, and that is asking you pretty much the same question, except here it is, hey, how far away is negative 3 from 0 on the number line? And you should be saying to yourself, well, that is 3 spaces away. It doesn't matter the direction that we're coming when we talk about distance. Distance is always a positive number. So the absolute value of negative 3 is also 3. So that leads us to things such as this. The absolute value of what number is 5? So what that is saying is, hey, what number is 5 spaces away from 0? And really the question should be, what numbers? Plural, because there are 2, as you can see right here. So you should be recognizing that x could be 5 and x could also be negative 5. Those are your 2 different answers that you really could get from this. If you did it on a number line, the visual, 0, you could have 5, you could also have negative 5, and they are both 5 spaces away from 0. Well, let's take a look at this. The absolute value of what number is negative 5? Well, what number is negative 5 spaces away from 0? And hopefully you're understanding that regardless of the direction that we're coming, we are always talking about distance as a positive value. So nothing is negative 5 spaces away, regardless of the direction. Distance is always positive. So this would be no solution. Can't be a negative number away from 0. Absolute value cannot be equal to 0. So we can take this idea let's look at x plus 2, the absolute value of equals 7. So, hey, the absolute value of x plus 2 equals 7. Hopefully you're understanding now at this point in time that really you're going to have 2 answers when you're dealing with these absolute value equations. The way that I like to think about this is, let's say I were to come in here and cover up what is inside these absolute value bars with, let's say, my pen. There you go, you can't see it. So underneath my pen is something. Pretend you don't know what that something is. Well, when you take the absolute value of this something right here, it has to be 7 spaces away from 0. So what is 7 spaces away from 0? Hopefully right now you are saying that, hey, I know it's 7 spaces away from 0. 7 is, and also negative 7. So those are the 2 values right there, 7 and negative 7, that are 7 spaces away from 0. But what is it that we are talking about that is 7 spaces away from 0? Well, if I uncover my pen, the magical moment, da-da-da-da-da-da-da, x plus 2 is 7 spaces away from 0. Therefore, x plus 2 equals 7, and x plus 2 equals negative 7. Those will be your 2 equations to solve for this x value here. So you can subtract 2, x equals 5. Here we will subtract 2 also, x equals negative 9. And if we take these and plug them in to check to see if it works out, hopefully it will. 5 plus 2 is 7. The absolute value of 7 is indeed 7, check. Next value, negative 9, let's plug it in here. Negative 9 plus 2, negative 7. Well, the absolute value of negative 7 is indeed 7, check 2. You can take that idea and you can just kind of keep running with it. Let's look at the absolute value of 2x plus 3 equals 4. Well, if I use my magic little pen trick, whatever is underneath my pen needs to be 4 spaces away from 0. So what is 4 spaces away from 0? 4 and also -4. So you take what is inside here in those absolute value bars. 2x plus 3, set it equal to the positive value. 2x plus 3, set it equal to the negative value. That represents the number of spaces away. And then you can solve both those equations. -3. 2x equals 1, divide by 2. X equals 1/2. Come in here, -3, you're going to be taking the same steps on these. 2x equals -7, divide by 2. X equals -7/2. Those are your two solutions there. If you take them and plug them in, they're definitely going to give us our same answer. Now let's look at another example here. Let's look at 3 times the absolute value of 2x plus 1 minus 2 equals 16. You're going to be doing a lot of the same things here, but first you kind of need to solve and you need to isolate the absolute value bars. Get these absolute value bars all by themselves on one side of the equation. And so you'd take the same steps you'd take as solving a regular normal equation, non-absolute value. First, we will add 2. 3 times the absolute value of 2x plus 1 equals 18. Now, some people want to come through and distribute, but do not distribute to absolute value. Do not. I guess we should put a little star by that. Don't distribute to absolute value. Please do not do that. The way we're going to undo this multiplication is with the operation of division. Divide both sides by 3. The absolute value of 2x plus 1 equals 6. Now, hey, let me ask you a question. If I cover that up and make that kind of disappear, the mystery thing underneath my pen right there, well, hey, whatever's under my pen has to be 6 spaces away from 0. What is that? Well, 6 and -6. Therefore, what is underneath my pen must be equal to 6 and also be equal to -6. 2x plus 1 equals 6. 2x plus 1 equals -6. Solve, subtract 1. 2x equals 5, divide by 2, x equals 5/2. Coming in here, subtract 1. 2x equals -7, divide by 2, x equals -7/2. Those will be your two solutions for this absolute value equation. Thank you very much for that. Let us now come through and give a little step-by-step process. 1. Isolate the absolute value bars. Get it all by itself on one side of the equation. That is your first and foremost goal. Then check it. Absolute value can't be equal to a negative value. If it is, you'd write no solution. I will give you a quick little example of that in 1 second. I think I did up top a very straightforward, simple one though. So that was 2. If you can proceed, go right ahead and proceed. Take what is inside those absolute value bars, make it equal to your positive, and then take what is inside and make it equal then to a negative value that you have isolated on the other side of your absolute value. That's a quick little cheat sheet right there. So let's look at one of these that is equal to a negative. I'll give you a very, very, very similar example here. Equals 18. So what we do first is we want to isolate these absolute value bars. So first thing we do is come through and subtract 5. -4 times the absolute value of 2x plus 1 equals 13. Well, we don't have it isolated, so we're not checking. We still need to come through and isolate. So now let us divide by -4. So we get the absolute value of 2x plus 1 equals -13/4, and when you have your absolute value bars isolated, that's when you want to see if it's equal to a negative. Let me ask you a question. Hey, the absolute value of something, whatever it is -13/4 spaces away from 0. I'm not sure how to be negative spaces away from something or a negative distance, so since I'm not sure, I'm going to use these little words right there, or little letters, to stand for not sure. Actually, no solution. Thank you very much. I hope you enjoyed it. See you later.